Let's take a look at this example. This time we're supposed to determine the magnitude and the direction of current I1 and IE. We're supposed to calculate also voltage across the current source and V1, voltage across resistor R1, and total power. So from where we're supposed to start solving this problem? Please keep in mind that we have a voltage source. Okay, this is my voltage source, this is my positive terminal, this one is my negative terminal, and voltage source is connected directly across my current source. So when we have parallel circuit, okay, and we have voltage already, so it means the voltage of my voltage source E is going to be equal to the voltage across my current source. That's why I'm going to write that my Vs is equal E, and this is equal 20 volts. This is also voltage across these two resistors. Okay, so it means that I'm going to have also 20 volts between this point and ground. Okay, so I can say this is V12. It doesn't mean that I'm going to have 20 volts across resistor R1 and 20 volts across resistor R2. Keep in mind these two resistors are in series, but the voltage V12 is representing the voltage from this point to ground. This is voltage across these two resistors together. Okay, so next I supposed to find I1. In order to find I1, I'm going to simply first find total resistance. R total is equal R1 plus R2. R1 is equal 2.7 kilo ohms plus 3.9 kilo ohms. Okay, so R total is equal 6.6 kilo ohms. Okay, if you don't see that, you can always use the calculator and simply add 2.7 exponent 3, because we talk about kilo, plus 3.9 exponent 3, this is equal 6.6 kilo. Okay, so I have total resistance of these two resistors. So in order to find the currents, I1, which is simply equal to I2, this is also, we can say this is equal I12. Okay, if you are going to combine these two resistors together, we can say this is I12. This is equal E over R total, where E is equal 20 volts and R total is equal 6.6 K. This is equal 20 divided by 6.6 exponent 3. This is equal 3.03 milliamps. Okay, this is my current, right? So I can say that I1 is equal to I2 is equal I1. 2 is equal 3.03 milliamps. Next, we're supposed to find the current which goes through the voltage source. Okay, we're supposed to find the current in the direction. So what we're supposed to do first? Please realize that if you are going to subtract, okay, from I12, okay, you can say this is kind of I total. If you are going to subtract from I total this current, you are going to find the current which goes through the voltage source E. So I can say that my I1 is equal I2 is equal I12. This is my also I total, we can say. This is my I total. So if you want to find IE is equal I total minus IS. Okay, why I call this I total? Because this voltage source is going to push the current, and this one is going to also push the current, so the total current is going to go through these two resistors. That's why if you are going to subtract from the total the value of this current, you are going to find the current which goes, okay, in this branch. So we have I total, which is equal, we found 3.03 milliamps minus 3 milliamps. This is equal 30 microamps. Okay, 30 microamps. So it means that my current IE is going to go in this direction, and is going to have the magnitude of 30 microamps. Okay, so next we're supposed to find V1, voltage across resistor R1. I'm going to use Ohm's law to do that. So I have V1 is equal I1 times R1, where I1 is equal 3.03 milliamps times R1, which is equal 2.7 kilo ohms. This is equal 3.03 exponent 3 negative times 2.7 exponent 3 equals 8.18 volts. 8.18 volts. Okay, so this is my voltage V1. Next, I'm supposed to find the total power. P total is equal, I can say my total current, I total square times R total. So I have my I total, we said, is equal 3.03 milliamps. So I have 3.03 milliamps to the second power times R total, which is equal 6.6 kilo ohms. This is equal 3.03 exponent 3 negative to the second power times 6.6 exponent 3. This is equal 60.59 milliwatts. Okay, so this is my total power. Again, we found I1, we found IE, we found VS, we found V1, and we found P total. So we can say that the problem is, so